Hello all, I am Isabel and I'm joined today with my colleague Shrey. We're both software engineers for Red Hat's Artificial Intelligence Center of Excellence, and we both work on the AIOps team. Today we're going to be looking more deeply into classifying different types of failing tests in continuous integration project workflows. The main motivation behind this project is that even though subject matter experts are able to understand how and why failures are happening, it's a very manual and very time-consuming process to do this at scale. And we can all pretend to be subject matter experts for a moment and understand this hand-annotated example here. If we look at the grid of passing and failing tests, we can classify most of them into one of a few different patterns. The first pattern is rows that are red with interspersed green, and this normally means a flaky test. Flaky tests are just tests that pass and fail across multiple runs over a certain period of time. We can also see rows with solid red chunks, and this behavior is almost always a new test failure, which is either a regression in the test or the product, which we can see here. We can also see rows with solid red chunks and white to the right. And this behavior usually indicates there's some sort of install test flake that's added when running in the release job. We can also sometimes see repeating vertical red bars, which normally means that the subsystem has a bug. And we'll find a set of rows that all fail together on the same run. It kind of correlates with this failure waterfall. So if there's meandering failures from bottom to top, right to left, this almost always means an infrastructure flake. And we can see here, this is just a little bit more in-depth explanation of each of these types of flakes. But if we want to have kind of a statement for what we want to get out of this project, our goal is that, given a test grid, we want to be able to classify and detect different failure patterns occurring over a certain period of time. Later in the project, we want to be able to aggregate these results to be able to analyze the primary reasons behind failures for each release. And let's dive into the code, which is our failure type classifier notebook. This notebook starts like many others, where we are importing different libraries along with some functions from our failure type functions notebook. We're also setting up access to our S3 endpoint and to our Ceph bucket to save our data, as well as adding in a framework to be able to run this notebook as part of a larger automation pipeline. This is some more of that framework we saw. And this is our overall test grid hand annotated example, but we want to look into our own data. So we'll select a specific dashboard and job and do a little bit of data manipulation to be able to understand this data. And let's just display the first 50 rows of a test to get an understanding of what the data looks like and be able to sanity check our results. With just a quick look, we are able to see a lot of the patterns that we discussed earlier. And we'll be using the tooling we created to detect the failure types and print a report, which we can see here. From this report, we're able to see the types and durations of each type of flake. For example, we can see that we detected the flakiness of test 6, which is apparent from this red and green interspersed together. However, this failure detection is currently a black box for users who are looking to dive deeper into the code. I'll pass it over to Shrey in order to break open this black box and take a little bit more of a detailed look as to how we came to these conclusions.
Thank you for the introduction, Isabel. So we have four different types of flakes here and the timestamps at which the methods predict that these occurred. So let's look at how the methods are trying to find these and how we are generating this report. So the failure type functions notebook contains the utility functions that help us to run the failure type classifier notebook. So we have metric template functions that help us unroll the data set and communicate with Ceph for storage. Then we have flakiness detection functions that help us in doing EDA and also calculating flakiness scores. Finally, we have the classification functions that we are interested in. So we have four different functions, and all of these take in the test grid as input and then return the timestamps at which they think that particular type of flake occurred. So the first function is to detect infrastructure flakes. So these are the flakes where we want to detect the diagonals at which the errors occurred. So we use a 2D convolution filter that finds these diagonals and then returns the timestamp at which these diagonals were found. The second type of function finds the install flakes. So if we see that more than 90% of the tests are not run for 2 or more consecutive days, then we record that period as an install flake. The third type of function uh, detects new test failures, where if we see that 6 or more consecutive failures occurred, then we record that period and return that in the report. Finally, we have the detect flaky test function. So the test grid gives us labels for when it sees a flake. However, it can miss certain types of flakes, which can be calculated using the calculate optimal flakiness score, and the labels can be modified using this function. So we have these four functions, and then we call them in the detect failures function, where um, we use that and return the final failure report. So we use these methods to generate this failure report. And once we have that for the selected dashboard and selected job, we run the analysis for all the dashboard and jobs, which is simply looping through the test grid data for all the dashboards, and then within the dashboards for each job, running the detect failures functions and generating that report. So once we have that, we either save results on Ceph or locally. Remember the parameters we defined in the beginning. We use those to communicate with Ceph and put the results there. We can also run this notebook in automation. So if we have switched on the automation flag, we can use this notebook to store the final outputs on Ceph bucket. So we have a pipeline in place called failure.pipeline. So it has two notebooks that run. So the first one gets the raw data, the raw test script data from the website, and we have defined all the parameters required for it to run. And once we have the raw data stored on Ceph, the failure type classification notebook takes that raw data, computes all these failures, generates that report, and then puts it back on Ceph. So if you want to run this in automation, you can use this pipeline as well. Finally, um, we saw that we can get the test script data and then detect different types of failures using pattern matching. We ran the analysis in automation, and as a next step, we would like to improve the analysis and we welcome feedback from both CI experts and data scientists. Thank you for your time, and we look forward to your contribution.